we're going to learn our third method of solving system equations, and this is called solving by elimination. Okay. There are 4 steps. First, we look at our equations, okay, and we're going to multiply one or both of the equations by a non-zero constant. Now, how do we decide which constant? We want to be able to have the equations, when you add them, totally cancel a variable. Meaning, we want the coefficients on the variable to be identical but of opposite sign. So, in our first example, okay, in order for the y's to cancel, I'd have to multiply this by 5 and this by 3. It's easier in this case to cancel the x's. And I notice, if I multiply the entire first equation by -6, I'm going to have -6x on top and plus 6x on bottom. Same number, but opposite sign. So, I'm going to carry through this multiplication and get a new version of my first equation. Okay. And now the second step is to add together my original second and my new first. And notice that the x terms cancel. And that's the goal of elimination, is to have a variable immediately cancel. For the rest, I get 23y is -46, and I can immediately solve for y. Now to get my second variable, I take this y and plug it back into either of the original 2 equations. The numbers are a little bit smaller on this one, so I'm going to choose to plug it into the first equation. And I get x is -4. So my solution is -4, -2. Let's do another example. Over here, I can choose to cancel either variable, but I like to cancel the x's here because 2 and 4 are multiples of each other. And in fact, if I multiply this first equation by -2, then the coefficient of x up here will be -4, and here it will be +4, and they will cancel. So my new version of this equation is -4x is -10 plus 6y. Okay. When I add these, the x's totally cancel out, leaving 1 minus y, or y equals 1. Okay. And again, once I have the y coordinate, I'm going to go back to either of the original 2 to solve for x. I'm going to plug it into the first one. So 2x is 5 minus 3, or 2x equals 2, giving me x equals 1. So my solution to that system is 1, 1.